Good afternoon, everyone, and welcome to uh, this webinar series. The theme of this webinar series is Big Data and the Future of Research in Africa. Let me start by thanking the President of the Nigerian Academy, Dr. Abiodun Egbetokun, for this glorious opportunity. And also, let me thank the organizing committee headed by Dr. Mohamed Awal Ibrahim for their relentless effort in making this webinar a reality. And also all members of the Nigerian Young Academy and all participants of this webinar series. Today we have three distinguished speakers amongst us who will be sharing their thoughts on big data and the future of research in Africa. Let me start by profiling these distinguished speakers in the order of how they will present their talk. The first speaker is Dr. Wesley Dosami. Dr. Wesley Dosami received the MSc and PhD degrees in electrical engineering from the University of the Witwatersrand in Johannesburg, South Africa in 2015, with his research focusing on condition monitoring. He also completed the postgraduate diploma in education with distinction. In 2011 and 2013, he was awarded the National Research Foundation Freestanding and Scarce Skills Scholarship. Afterwards, he proceeded for his postdoctoral research in the area of sustainable decentralized renewable energy systems and remote applications. Currently, Dr. Dosami is an associate professor at the Institute for Intelligence Systems, University of Johannesburg, and a full member for the Electrical and Electronics Engineering in that branch of IEEE. He's a senior member of the South African Institute of Electrical Engineers and an affiliate of the African Academy of Science. Professor Dosami's area of research is in condition monitoring and diagnostics with computer intelligence, analytics, and optimization in different application areas, which includes power and energy, etc. Is actively involved in several related industry and government initiatives and technical committees. Please can we welcome Dr. Dosami. Secondly, on our list of distinguished speakers, we have Dr. Olumuyiwa Sunday Ashaolu, who obtained a BSc in Civil Engineering and MSc in Engineering Analysis from the University of Lagos in 1991 and 1995, respectively. He also became the first person to earn a PhD in Engineering Analysis from a Nigerian university in the year 2002. He was a postdoctoral scholar and lecturer at the Industrial and Information Engineering Department at the University of Tennessee, USA, between November 2003 and October 2005. He was head of department and is presently an associate professor in system engineering at UNILAG. His research interests, expertise, and publications span mathematical and engineering modeling and artificial intelligence. He is a recipient of several scholarly awards. Dr. Ashaolu is a registered engineer and a member of several professional bodies. Please can we welcome Dr. Sunday Ashaolu. Last but not the least on our list of distinguished speakers, we have Mr. Joshua Adeleke. Mr. Joshua Adeleke obtained his BSc in Computer Science and MSc in Electrical Engineering from Babcock University and the University of Cape Town, respectively. He currently works in legal data as a big data consultant, where he builds and supports enterprise data lakes and data warehouses. Prior to joining legal data, he was in the financial services sector, working as a core banking application specialist at the United Bank for Africa PLC. Please may we welcome Mr. Joshua Adeleke. Having profiled the speakers, we'll go straight to the agenda proper. We expect that the speakers give a presentation for 7 minutes each. You may wish to use your PowerPoint or you may present without slides. So we'll be starting with Dr. Wesley Dosami. Dr. Wesley Dosami, please.
Good. Thank you very much for that kind introduction. I hope all of you can see my slides. Just before I get started, in the brief time that I have, I wanted to focus at a high level and give some insight and share some thoughts on data and the role of data in the economy and especially in research and innovation. So to do that, I thought I would add in a bit of history because the role of research and innovation, has some relation to this. And if we think about the where data comes from, we can start all the way from first industrial revolution. Think about innovation then. The picture in front of you, all of you are well aware that this didn't occur in Africa. It occurred in the Western world. The clothing of the people in front of you will tell you where steam power in the late 1700s was thriving. And it took almost 100 years later to reach us. The same similar case with the second industrial revolution, where we had electricity and motors, for example, that allowed the assembly line. For the late 20th century, when we start thinking about the third industrial revolution with automation and computers, there were some countries in Africa that started to get involved in that industrial. But the issue there was we're mostly consumers. These kind of technologies were not being created here in Africa. And now we at the crossroads. We at the fourth industrial revolution, and most of you are familiar with some of the technologies there, because it's a confluence of different technologies, and some of these technologies are not new. If you look at AI and ML, computational intelligence techniques, they were available a long time ago, but they are starting to come to the forefront now. And if we think about a golden thread through all of these technologies in fourth industrial revolution, we start to think about data, if we can pick one out. So there's kind of whether it's a feature or some kind of causal effect, we know that data growth and data has an important role, particularly in research and innovation. Just to give you an idea, the data growth is tremendous. If we look at the data growth on the graph in front of you from an IDC study, in 2020, we're around 40 zettabytes. I just put the zeros in front of you to try and give you an idea of how many bytes we're talking about. And if we look at the 2020 zettabytes, 40, we're expecting around 2025, in the next 5 years, for that to quadruple, times 4. So where is this data coming from? It's coming from various sources: Twitter, Facebook, social media. We do digitally these days creates data. And what's happening is, I like to think of it as truly the invisible hand. And the way that it's done is through pervasive computing, particularly those things sitting next to you, your mobile phone. They're extraordinary in collecting data. Just by the way, on the presentation, I thought that I can share a very insightful book. It's not a research or technical book that can get you to understanding as to what this data is being used for. It's allowing us to understand, humans in a different way, in a much more detailed way. Whether it's your body or whether it's your behavior, we are able to understand it much more. The question is, who's using this data? In the past, we found governments had, the majority of the data, but now it's becoming decentralized. You have big tech companies that have this kind of power at their fingertips now. And so countries are grappling with it. And you find in the past, 2 to 3 years, they are developing strategies, which I invite you to go and look at some of those strategies and how they are positioning themselves around data, which is becoming a very, very influential part of the economy, not just the economy, but research and innovation. So it being a new goal, it's we can mine data to certainly improve our insights, and companies have already realized that, and they're investing big data infrastructure, and not just businesses, but now governments are starting to also come around to the table. So whenever we move forward now, we need to start thinking as researchers and scientists of data as being a resource, and a critical resource that can act as a macroeconomic feedstock for development. And think of it as being a truly, the true invisible hand that's driving growth and transformation. And that is why there's such competition and contention around data itself. So with regards to research and innovation, I always put this picture up just to give you an idea. If we see this somewhere posted, we'll probably think this is really smart. It's great. It's a water delivery system. It's a robot delivering water. But when I think about it and I look more deeper into it as a researcher and innovator, I start thinking maybe this is more innovative. It's more water, it has more impact. It's an electric delivery vehicle. And then you look a bit further and we see something like this. This is the Hippo roller. So to me, that third picture has the most impact. And it all boils down to context. So when we think about data, we have to say, how do we innovate using this data through our research to meet the context and meet the time on our continent. So for those of you that haven't had a look at this, I think it's a good read. The Agenda 2063 definitely forms a framework which we should always go back to. Recently, there was also a report by the African Development Bank which speaks a lot about technology and the role of data in how we can go about moving towards these goals that are laid out in Agenda 2063. As a few points before I end my talk, data can certainly play a critical role in all our research. Be it, if you think about the power of data, just to give you an example, if a country has the medical history, let's say, of its citizens, researchers can use that kind of platform to develop better chronic medication for the entire country. And that's a huge plus. If we think about a repository for geospatial data, where we can find out network coverage and detailed land use, that can start informing our agriculture practice and also our telecommunications industry. So there are hundreds of thousands of different examples like that within each of these sustainable development goals. And data itself plays a huge role. And we should think about how do we harvest and collect our data in Africa and process it and manage it and secure it in Africa, and then formulate knowledge and information and innovate different types of aspects through our research in Africa itself. And just a few points maybe to leave researchers with is that we don't have to wait for, I believe we don't have to wait for, continent strategy or government strategy. In our own research labs, we can start by thinking about and making plans for our own ethical collection of data, our own safe and secure management of data, and also our own deployment of models and using that data in a responsible way. So formulating our own data ecosystems around our own research. And just to leave you with the last thing from Charles Darwin is that, it's not the strongest or most intelligent, but how we can best manage change.
Okay. Thank you very much, Dr. Dosami, for this wonderful presentation. I think I would like to take the second speaker before we now ask general questions directed at individual speakers at the end of the presentations. Thank you again, Dr. Dosami. The second speaker that we will be calling upon is Dr. Sunday Ashaolu.
Yeah,
Dr. Sunday Ashaolu, please.
Thank you for having me, and good day to all our listeners from around the world. I'll be making a brief speech without slides, and I'll talk about research generally, give an overview of big data, talk about research in Africa, incorporating big data analytics, as well as give some conclusions on the way forward. Research itself, as the word suggests, is to take another look at something in order to uncover or discover, underlying traits. Formally, is an honest and systematic approach for examining facts and their meanings or implications with respect to a given situation or a problem. It is the scientific undertaking to discover new knowledge based on the existing facts, testable assumptions and principles. And what's the goal of research or the purpose of research as a whole? Basically, is to explain the state of any system or to be able to predict its output when given an input. And it's the various inputs into various systems that are referred to as data. It is when these inputs or data are processed that they become meaningful information that can assist us with our decision-making processes. Now, traditionally, we are used to collecting data from observation, experiments, survey samples, and so on. And we store these things in databases, use statistical tools, traditional programming, and all that to analyze them. But such is becoming insufficient due to the large volume and variety of both structured and unstructured data that we now have in this digital age. We live in an era where there is a continuous availability 24/7 of all kinds of transactional logs. For example, interactive web pages, sensors from internet-enabled devices, all forms of gadgets, CCTV, mobile phones, everything you do, any moment you are generating data. Same thing with industrial processes. And it's easier, to actually track all this data in our time. Consequently, we find out that the traditional tools of database processing and statistical analysis are not really sufficient, as I've said, hence the need for managing large volumes of both structured and unstructured data, as well as processing them. Consequently, data science evolved what is now known as big data analytics, or BDA. And BDA simply encapsulates the collection of large amount of raw data and manipulating, querying, or processing such for decision-making purposes. Why do we do this? We want to derive insights so as to reform our actions or to predict outcomes, as well as develop coping strategies. In fact, most of the time when you use your browser, you find out that some form of adverts are suggested to you. This is based on data science, okay? The browser sort of keeps some records as to the places you visit, the things you do, your interests, and as such is able to recommend movies for you or the certain types of clothes or shoes or gadgets or whatever. Or if you are somebody interested in traveling, you find out you are being suggested to about certain places to visit, oncoming rebates, vacation resorts, and all that. All this is based on data science. When you now take it to a higher level and deal with large volumes of data, you have big data. And a possible future application of that is sooner or later, our children or grandchildren may not need to have personal cars or own their driver's licenses. Just with a click of a button on their phone or tapping something on their wrist or whatever, they may be able to just call up an autonomous vehicle that will come and pick them from one place and drive them to another. And a lot of corporations like Google, Tesla, and so on, they're already experimenting with this. You have prototypes, vehicles that know the state of the environment, the road itself, can interact with you, even respond to speech commands and all that, and be able to navigate itself seamlessly, avoiding obstacles, just to take it to another location. All these are possible. Today, we all make use of a Google Map, MapQuest, and stuff like that. But all these things are evolving. And the end goal is to make life easier, so to speak, more flexible, so that we can really focus on enjoying our health, relaxing, and having a lot of the drudgery taken away by automation and intelligent systems. So when you now talk of research in Africa, how do we incorporate big data? Of course, there are so many areas we can do that. In entertainment, banking, insurance, transportation, healthcare, manufacturing, education. And there are all kinds of analysis we can perform with big data. There is descriptive analysis, to help you understand the situation. For example, the sales unit of an organization, the predictive analysis, for example, the market unit, what's going to happen, what are customers going to ask for next, the diagnostic analysis to help you find out what is wrong, what is happening in the system, and the prescriptive analysis for management to take an overall view of everything and make optimal decisions. So problems exist, in Africa, all kinds of problems, just as everywhere else. And it's actually a vast amount of data in many disciplines. We only need to harness this. Consequently, Africa should invest in ICT and basic infrastructure, for example, energy, provide computing resources both for schools and all that. Even the society, have digital libraries, get people involved, people aware, people educated. We need to develop skills necessary for using new tools and devices. All these new technologies that are coming up, we need to change. And we're actually adapting. About 20 years ago, how many people had email accounts? But now almost everyone has several social media accounts, and we are using all kinds of apps on our, portable devices and so on. So we need to develop more in all these things, as well as train and deploy more experts in informatics, artificial intelligence, and so on. Yes, we started, but we need to catch up. And we can easily catch up with the developed world in the sense that the major chunk of this thing is software driven. So if we have the interest and we see the necessity, we can actually, do some interesting work in all these areas. And there are specific areas that I think we need to focus on as Africans include governance, healthcare, agriculture, commerce, security. Especially in healthcare, we need to look at tropical diseases, personalized medicine. For example, COVID-19 is raging and everyone is waiting for a vaccine. But must this come from the Western world, so to speak, or the developed nations? How do we as Africans actually react to this virus? Are we really studying the strains that are here, looking at our environment, our climate and all that, our diet, our immune systems? So we need to do localized research. And we need to harness, all the data we have to actually come up with something suitable for our citizenry. Similarly, some nations have been doing a lot of work in smart agriculture, precision agriculture, Nigeria, Kenya, South Africa. I believe we are all already doing some interesting work in this area. So what's the way forward to conclude? There is need to develop capacity locally and deliberately invest in research as well as artificial intelligence. Artificial intelligence, or AI, simply means creating systems that can emulate or simulate human behavior. You know, when you sort of encode, animate intelligence into systems so that it can take decisions or react, respond to stimuli, learn with time, with minimal or no human intervention. Presently, many endeavors going on in sub-Saharan Africa are driven by foreign interest or corporations. Our governments and industry should see academics as partners for social development. This is imperative. We're actually going to meet up with the Sustainable Development Goals as well as Agenda 2063, you know, as mentioned by the first speaker. And we as researchers, we must learn, we must unlearn, and we must relearn. We should not be intimidated with all these buzzwords that come up from time to time, all these new technologies. Yes, we can't catch up with everything, but we don't have to be ignorant. We need to know what's trending, you know, see the relevance to our various areas, and at least mentor, you know, probably a younger person in a research thing if we think we don't want to go that route, but that such a young person can actually go deeper and see how to apply such technology to our various disciplines. Thank you.
Thank you very much, Dr. Saudu, for this wonderful talk. It's quite appreciated. Next, we'll move to our next presenter or speaker, Mr. Joshua Adeleke. Mr. Joshua Adeleke, please. Do we have Mr. Joshua Adeleke?
Sorry, I've been speaking on mute. Sorry.
Oh, no problem.
Yeah,
no problem.
Can you hear me now?
Very clearly.
Yeah, so thank you for having me, and thanks for the presentations, Professor Dosami and Professor Ashaolu. I'll be talking more like about getting your hands dirty with big data analytics. Thank you for giving a good introduction too, so I don't need to talk too much about data. But what I'll just mention about big data is the fact that it is big because of the data that comes from all the different advancement in technologies. Say, for instance, your phones that can do switch between different cell towers, you know, different IoT devices. And when I say IoT, Internet of Things, and sorry, I'm not using a lot of slides. I probably only have one slide that I'll project much later on. So I'll do more talking. So what I was saying is that it's data. So when we say big data, it shouldn't scare anyone. So I believe the big is because of the unstructured, the chunk of mass of unstructured data that has been added to it. Usually we have structured data in the sense of pushing data into relational databases that we know very well as Oracle and SQL databases. But now we have much more in terms of XML tags and JSON data, semi-structured data, and mostly unstructured data. And that's where we get a lot of the petabytes, zettabytes, and the whole chunk of data that makes it big data, and then requires for another kind of sink. When I say sink, I mean a database, another kind of database where we can store this data. So if you ask me what is big data, I'll tell you it's a term used to refer to a chunk of data that it's now more than just structured data that goes into relational database tables. Now we have sensor data, we have URL data from your web crawls where you go around. Sometimes you find that you browse certain locations, URLs, and then the next time you browse it, it suggests something similar. So they're putting something, cookies and all those things, so that it can kind of predict and check, okay, it's our, is Professor Ashaolu. Now he went to do something in systems engineering, and now he needs to, he needs something related to that as a suggestion, So what I would also like to mention is the ETL process. Maybe it's time to project my screen now. Let me know if you can see my screen.
Okay. Yes.
Okay, so the architecture of data lakes. So basically, all these kinds of data go into what we call data lakes. So say, for instance, you're talking of big data analytics. Before you can explore the data or exploit it as it were, it needs to be inside databases that we call data lakes. And the difference between data lakes and what we have before is that data lakes have different kinds of data in its raw formats, where you can now put a data warehouse on top and different kinds of maths on it where you can exploit the data. So say, for instance, you have data coming from sensors. Say you're monitoring the animals that in a farm, say a cow and a cow rustling, and they're stealing cows. And then you put sensors on each one, and it sends back data on where the cow is grazing and all that. And then you begin to sync that data in its raw format into data lakes. Now, you find that on the left-hand side, OLTP or ODS, that's online transaction processing or Oracle data store. And that's more relational, and that is what we're used to. And then we have a file, the DB data. We have also the streaming data, which a lot of people capitalize on nowadays. And simply put, what streaming data is that you analyze, you push your data or ingest your data on the go. So you don't, so there are mainly two types: the batch processing and the stream processing. So it's batch in the sense that you're pushing the logs into a place, and then it takes time for it to be ingested at a future time. But when it comes to streaming data, you're doing it like in milliseconds, quickly. And so some of the use cases for streaming data is where you have fraud analytics, where you quickly want to pick up if someone is fraudulent on banking systems, as an example. It's also useful for things like notification systems. Say, for instance, you're monitoring a fleet of cars, and you want to know how those guys the speed at which your drivers are going, as an example. Then you need to be getting all those information and analyzing it quickly, put it on dashboards. An example is your Power BI dashboards, where you have where you can display all those metrics, and they see that, okay, driver A is going at 80 kilometers per hour, it's still within its limits, but driver B is going to get us a lot of fine. So let's tell him to, reduce his speed. And these are examples of the notification systems and the things we enjoy from streaming data. So basically, we have the batch and the streaming, and then it goes in its raw format into data lakes. And on that data lakes, on the data lakes, that's where you put if you want to do your modeling, and eventually maybe some data warehouses, you can do that on the raw data. But then you have an enriched data. And really what we're enjoying from big data analytics or big data itself, it's a richer data set. It's a richer data set where you have a data set where it's not just, as an example, for me, if I'm going between places and I'm using my mobile phone, And so it gives an idea of which location Joshua is now. Joshua has moved from Lagos to Ibadan. In Ibadan, will he get the services he's used to? Can we give him another set of services? You know, things like that is giving you geographical location. Another example a lot of people will be used to is Uber. So Uber uses big data analytics to get a lot of details. And with Uber, you put your name, you put even your banking details and a lot of things, you know. So Uber is using that rich data to do business, and they're in the transport business. Maybe sooner or later they can go into other kinds of business based on the rich data set they have. So yeah, big data analytics has a lot in store, and the use cases I've seen, because I mostly operate in the telco sector, it's a lot of products are being churned out because of the rich data set that we get. So basically we get location data and cell tower data from our base transceiver stations, and then at a point you look at a place like say, okay, so I'm in South Africa, so a place that in Joburg CBD, where you have a lot of people or congestion, and then you find that maybe there's a lot of drop calls because at a particular time people are busy either using data or doing voice calls, SMS. And then what that tells you from our analytics is that at this point, we need to boost the resources, the tower resources in that area, so it can accommodate our customers, and then we don't get negative feedbacks that come. This thing doesn't go through between 12 and 4 p.m., you know, things like that. So these are the kind of things we use the data we get, you know, to mine information and to service customers very well. Another thing that we use it for is, I think one of the use case that was really helpful was also the billing systems. So say for instance, you can get if you're a postpaid customer, you can get the number of calls you made per month and the people you called, so that you can fish out if anybody is, you know, sending you fictitious bills. Say for instance, for data bills to the kind of sites that have eaten up your data. So we send those kind of things, and simply put, what we do is to clean up all the URLs that we have gone to and the user has used, and then we look at, okay, for this guy, this one has used 1 GB for CNN News, you know, and all that. So we itemize that bill and send per month. We will not be able to do that with relational DBs. That's because for the size of URL alone, we're looking at terabytes per hour, you know, and it's a lot of data that needs to be cleaned up. So those are the use cases as a practical example of what we can use the big data for. And I know
Mr. Joshua, please. I'm sorry to cut you. Please, can you just round off? So sorry to cut you.
Not fine. Sorry, I knew I would exceed if I get on it. Sorry. So just to round off. So it's just a lot of things we can do with big data, and I know that in the course of the discussion we'll be able to we'll get questions or where we can even talk more about the usefulness of big data. Thank you.
Sure. Yeah. Thank you very much, Mr. Joshua, for the wonderful presentation. I will just quickly summarize what the presenters have shared and ask a few questions and direct it to each presenter before we quickly take also the questions from the participants. Dr. Dosami talked about data, the invisible hand. Quite an interesting aspect of big data analysis. And he very importantly linked the usage of this big data as to how we can achieve the sustainable development goals. He talked about how this data can be harvested and collected, and importantly, how this can be used in Africa. Dr. Dosami, please, I would like to ask you a few questions. I hope you're on hand.
Yes, please, thanks, go ahead.
Dr. Dosami, please, I hope you're on hand. Okay, perfect. Yes. Dr. Dosami, based on your presentation, I'll throw a few questions and hope that you do justice to them. Question one, for a layman, how do you get the necessary information from big databases to a layman? That's my first question. Secondly, can big data database technology be used in, for instance, or what specific disciplines do you think you could use big data for, more importantly, in terms of rating the disciplines that we could use big data for? And how can we incorporate this into conducting very meaningful research? Thirdly, how do you think big data is the definitive solution for the reliable prediction of pattern and trends in Africa, and why? Right. My fourth question, what are the core areas, or if you like, research space that machine learning and artificial intelligence, which of course use a large chunk of big data, what are these main areas that this machine learning and artificial intelligence have probed into in research in Africa? Of course, we know this has been done, used more in developed nations, but how much have we done in Africa? And then lastly, what are the exact tools, data analysis tools that, for instance, the social media have particularly taken interest in? When I say social media, I mean Facebook, Twitter, etc. Thank you very much. I would give you some minutes to answer these questions while I head to the other presenters.
Okay. Thank you, moderator. So there's the first question in terms of information from a big database. I think first, just so everyone can understand, we need to know that there's a difference between data, information, and knowledge. So when we speak about big data, we need to understand that we're referring to very large data sets. And as the previous presenter also mentioned, that a lot of it is in raw format, or some unstructured. And if we want to use or gain information from those data, we need to be able to and also to build knowledge from the data. We need to have an entire data ecosystem that you would have. An example of that was shown as well. So it's really a collection of infrastructure and various applications that you need to have that kind of data management and analytics to be able to extract information from a big database. With regards to your second question, in terms of the disciplines, I think that yes, certainly we will benefit. We really need some local, data ecosystems and for the continent. And it's critical because scientists in Africa need the will have the opportunity to research and innovate from our own data. The example of the vaccines development was given by one of the presenters. So there's so much we can do in alignment with those development goals if we have our own ability to collect, manage, and secure, and then utilize our own data. Of course, we'll need data centers and platforms on the continent to be able to do that. So African research and science depends on this, us having this kind of infrastructure. And if we think about it being a definitive solution for reliable prediction and pattern trends, yes, most certainly. And it's more than that as well. We need to acknowledge that the more we are able to have our own data collected on the continent and utilize the resource for ourselves, it's an enabler for the continent to grow. I think one of the areas we looked at, what are the core areas in research spaces? So with regards to ML. So ML, AI, there's different pockets where it's being applied, but we're seeing mainly over the last 10 to 15 years, penetration in terms of, in Africa, penetration specifically in the service sector. So you'd find, like, for example, your financial service sectors are much ahead of other sectors in terms of deployment of machine learning and artificial intelligence. But the important thing is where we would like to see it happen and where we need it in Africa. And that's particularly in sectors like some of them were mentioned, healthcare, agriculture and energy, and certainly peace and security, for example, on conflict management side and conflict resolutions. So those are the areas we'd like to see ML and AI, and I think it can play an important role. Okay. Finally, on the data analysis specific tools, we say that social media, we know that it's a mixture of various different types of data, images, posts, text, and so on. So it's largely unstructured, and there's a variety of tools that you can use to extract the data, perform web scraping, and then build your models. Some of those models were spoken about in terms of recommender systems, for example, if you want to recommend a particular product or you want to use for marketing, or you want to try and sell something or innovate. But particularly in AI and ML, you'd use natural language processing and sentiment analysis to do that. And these are key mechanisms that we can use. But remembering that when we deploy this kind of models on social media, we need to always be sensitive to the impacts that it can cause and also ethical considerations. Yeah, I hope that I've not taken up too much time. Thanks.
Okay, thank you very much. I would like to point your attention to two questions that perhaps you missed, somehow during your answer session, so that you could shed more light individually to these questions. Just like I mentioned, how do we get to a layman, for instance, how do we get necessary information from big databases? Please respond to this.
Okay, so it depends on what you would like, where you would like to be in that ecosystem that I was speaking about. For example, now we have, when you speak about a layman, a person who's very in tune or in touch with their particular application, but may not know about what's happening on the data side. So an example of that is business insight, business intelligence, where you would have, for example, dashboards, but that's at the end of the ecosystem, the output of it. So you'd have very structured dashboards so that it becomes a usable format and an understandable format where let's say, executive management can take insight out of data. And that goes back to what I said, the ecosystem. So there's no easy way of taking large unstructured data sets and then just performing it on your own. When we talk about large data sets, you need that ecosystem. But it's important, like I said, in research, is that an innovation, and if you want to start on your own, is starting small on your own, and then working and developing your own data ecosystem, which you can scale up after that. Yeah.
Okay, quite interesting. And lastly, one of the questions that you somehow missed. For instance, I personally have been working on, harnessing data from biomedical experiments, if you like, and I've used it recently to predict, some structural and chemical characteristics, of this material. What area specifically in Africa have we really used big data to probe into in Africa specifically to date?
Yeah. So like I said, we have a huge number of areas we can apply, and sometimes when we think about data, the real innovation comes from looking at the data, and we may be, let's say, for example, using, like you mentioned, you look at maybe the chemical components of a particular data set or constituents, let's say. And you'd find that some of the data we have is so useful in a different field or discipline, and it can be extremely useful in a different place. And so what we really need is, in terms of, having a cross-platform so that other researchers from other disciplines can access it. I mentioned some of the key areas is definitely we need to look at is healthcare. There's different aspects of healthcare. I mentioned one is on chronic medication. I think this is because government spend a huge amount of money on chronic medication every year. And if you are able to understand, in terms of, which people you can assign generic medicine, for example. So the healthcare data is very important. That's definitely a big sector. The other one is, and it goes further than that. It's also image, X-ray image, radiology, and so on, different types of data sets in medical. And then agriculture, I mentioned one about land use. So having land use information tells us a lot about how, and also information about, that particular land or piece of land. Understanding that can really improve the way we do agriculture in Africa. And it's important for our food security in Africa. And of course, the other one is the energy aspect as well. Yeah.
Quite interesting. Of course, we're really enjoying the way you linked some of these applications to achieving sustainable development goals. We may come back to you with questions from the audience soon. Thank you very much for now.
Thank you.
Please, Dr. Ashaolu, please.
Yes, I'm here.
Thank you, sir. I'll just quickly have a summary of what you presented before I throw a few questions. You talked about big data analytics and try to link it directly to the goal of our research. And of course, you mentioned that the key reason for adopting this is to be able to predict output when giving an input. And of course, you mentioned an array of applications. In fact, moving forward, you mentioned what could happen in the very near future in terms of what we'll be doing with autonomous vehicles, etc. And importantly, you mentioned how we have been using big data in Africa in terms of policy making, governance, of course, agriculture, security, very important, and also in the face of the pandemic, healthcare. Sir, please could you shed more light on these questions I'll pose to you. Now, question one. What, in your own opinion, do you think we should be quite aware of in terms of using big data to predict a a particular event or research event in Africa? If we want to go into prediction in terms of how data have evolved in Africa, what do you think are the key things that we need to look at?
Oh, thank you, Mr. Moderator. First of all, I'd like to mention that, you know, with the way things are going, sooner or later, everyone will get on board, you know, with AI, big data, and allied technologies. And one thing that's going to happen, in fact, is has already started, is that companies and institutions, you know, they'll be more careful in keeping data. That's the first thing. We you know, in Africa, we need to take more care about actually storing and noting our data. Then they will begin to implement systems or consult experts to look at such data in order to discover unknown problems or to profile solutions to lingering or recurring issues. So traditionally, we have a lot of data that we didn't really care much about. You know, we go to a lot of offices, all kinds of archives that flood, rats, and insects and what have you, you know, have just been feeding upon. But now everyone's going to be careful about actually taking the data and storing it. And since we now know that, oh, you can actually mine your data to get some useful information, then they begin to implement systems or consult experts to help them take a look at their data, you know, so as to make recommendations to improve their systems. And the oil and gas sector, they're already doing that. The financial services sector, they're already doing that. You know, as was mentioned about fraud detection and all that. So the implementation has started, but a lot more people are going to get involved. And the benefits will be, we have intelligence systems that are up and running all the time, and things will be much more flexible. Yes, all these BDAs and what have you, they help us with predictions and all that. But at the end of the day, they're not going to totally, you know, remove or replace the human experts. You still need to have some experts in various domains who will be able to look at what is the output we are getting from these smart systems. Are they in line with reality? Are they suitable? Are they sustainable? So human expertise is not going to be totally discontinued, but it's going to be augmented and supplemented with intelligence systems driven by data science and big data analytics.
Okay, thank you very much, sir. Secondly, in terms of data-driven researchers, for instance, personally, I supplied data to some data scientists recently. Of course, during our interaction, I was told that if I deposit some of my data in some databases, of course, any researcher anywhere in the world could just pick this data and use it even without consulting me. So this takes me back to this question. For data-driven researchers, how can they remain independent with the hope that this expertise will not be misused?
Okay, that's an interesting question. I'll say that independence is relative, especially in this digital age, where you leave an electronic footprint along your way, you know, and depend on others for some service or resource. I mean, if you don't want people to sort of have anything to do with you, or you want to remain totally anonymous and all that, then don't get on the web. But the moment you begin to use all these smart devices and online resources, one way or the other, you know, irrespective of the kind of security that is put in place, privacy, you know, enforcement and all that, there will always be vulnerabilities. But as long as there are agreed protocols and standards to follow, and with professional ethics to guide everyone, by and large, we all be fine. Deviance will always arise, but the system must be able to detect those who misuse their expertise or abuse their position. There must be sanctions for violators. Okay, but in as much as there are great protocols and everyone tries to, follow the standards, yes, we will be safe. Things will be all right. People only need to have access to what they are supposed to. But as I've said, there will be hackers, there will be all kinds of trends, but the system will be able to detect them and effectively deal with such. Thank you.
Quite interesting. Just for the benefit of some of the participants that, of course, are interested in diving into this area of scientific importance, please could you suggest a best online course to learn big data analytics?
Well, there are numerous resources on the web, and I consider it subjective to aside that a particular one is the best. But there are some good tutorial sites out there. For example, there's there's an organization, a foundation doing a lot of beautiful work in Nigeria. You have a CodeFest dealing with people even from primary school level. There's also Data Science Nigeria. datasciencenigeria.org. It's good for tertiary level students and professionals who want to venture into data science, big data, machine learning, and all that. Okay. And there's another one, dataflare.training, data/flare.training. They have a lot of modules and courses that one can actually take. So doing basic research about some of these things and looking at some of these resources, one can pick up a few things at his own pace. A lot of free good tutorials on these sites. Dataflare.training as well as datasciencenigeria.org.
Okay. Yes, thank you, sir. There's a very interesting contribution that you made, how big data can be used in the education sector. Please, can you consolidate on some of the things you mentioned in terms of how data mining or usage of big data would advance the education sector in Africa?
Well, our educational systems are just more or less getting automated in this part of the world. And, the COVID pandemic has shown us that we actually need to take a look at intelligent, interactive, and online systems, to improve our systems. We can't rely only on the traditional chalk classroom system. So with big data, yes, and actually an institution can now take a comprehensive look at, which kind of people apply to our university, okay, which ones get admitted, how do students actually cope with, the structure we have in place, how many people drop out, which courses give problems. By moving most of these things online, we're able to track a lot of things, and the BDA or Big Data Analytics, we allow them to be able to generate a lot of useful information from the system, so that they won't only be able to deliver, classes, exams, and all that, but they'll be able to actually see what are the bottlenecks in the system and be able to resolve it, as well as better integrate with, the outside world. For example, last year we ran a pilot project in we did what is called interactive from my department and students from Dayton University, from the industrial engineering department, they are mid-level, and systems engineering students mid-level. They took a joint course that was designed and taught, by myself and a lecturer, in their equivalent departments. And students are able to learn how to relate with people across cultures. And we're analyzing the overall system to actually, deduce some useful information as to how to improve our operations. So you can do that on a large scale, and the educational system will be much more effective in the long run.
It's quite interesting. And lastly, I'm very sure this is quite mouth-watering to a whole lot of participants who really want to dive in, and even for big data scientists who want to collaborate. Is there a pool of experts somewhere we can get a pool of experts in Africa where, if, for instance, I want to collaborate with a data scientist, I could go into those archives to draw out data scientists that have research interests aligning with areas of interest for a particular interested collaborator?
Yes, indeed. There are experts in data science, artificial intelligence, and what have you. And incidentally, the Nigerian Academy of Science, they hosted a workshop also last year in November, basically on big data, and some experts from the diaspora, Africa, nationally, were there. And so such a office can be consulted by governments or corporations. I'm sure NYA, even with this, is already doing something too. And there are other professional bodies like the Nigerian Society of Engineers, the Nigerian Computer Society, where you have experts, who are actually focused on that as their own specialty. Yes, so the experts are available.
Okay. Thank you very much, Dr. Ashaolu.
You're welcome.
We may come back to you with questions from the audience as well. Thank you. Mr. Joshua, please. Mr. Joshua.
Yes, David,
Okay.
I'm here.
Okay, good. I'll just quickly summarize what you presented and then ask you a few questions. Of course, you mentioned, how we could get our hands dirty with big data analytics. And of course, you just, consolidated on the other interpretations given by the other presenters on why it is called big data. You interestingly mentioned that you shouldn't get us scared because, of course, it's just because it's sourced from a whole lot of sources. Interestingly, you talked about the architecture of data lakes, which I found very interesting. And of course, you mentioned how batch and streaming of this data could be, put into these data lakes for instance, policy making, very good research, etc. Now, this, of course, your thoughts are quite interesting and leads me to a few questions that I would like you to shed more light on. Moving forward, what type of new, for instance, human task do you see data analytics or big data analytics playing a key role? Of course, big data are being used to predict human trends. But moving forward, what new human tasks do you see big data analytics playing a key role?
Okay, so for the new human task, I don't particularly think it is new. I think it is the scale at which we are now doing it, right? So take, for instance, the data analysis where people query data. You run SQL queries, as we know. People run SQL queries against data to get results. There is a lot of people doing that. There are lots of people doing that already. But the scale at which we'll be doing that now will need you to now begin to think of, how to run your, even if it's simple select statements, to run it across petabytes of data. Now you need to optimize. And so when people say that you can drop out of school, this is where they see that, okay, school is important, where your optimization skills now come into play, and you begin to layer your queries in such a way. And I'm using data analysis as an example now, where you now layer your queries in such a way that you get faster results. Because to be frank, these queries, when you send, say for instance, your USSD code, sorry, I'm using telco. I'm very into telco. When you send your USSD code, say for instance, *121#, it goes to query a base and it must return at a particular time. So that query, although it is querying a big base, it has to return quickly. So what I will say is that the human task that we are seeing now is another level of data analysis in terms of when you talk about mining computational intelligence, you talk of data scientists and the models. You talk of mathematical models that, works, not the ones that, you just run on test data, and then on live data, it is not up to par, So these things we need to build competencies in this area. And I tell you, we need to go back to our tertiary institutions, where we need to now bring that knowledge of mathematics. And I hear you say that some institutes where we can liaise with as data stewards, data scientists, even data engineers. I know that AIMS, Institute of Mathematical Sciences, is doing a lot, and converting the people who are coming in into real data stewards, that can hone their own skills based on what they have been exposed to. So you can interact with those people. And for data engineers, I happen to do a lot more in data engineering, and those are the ones who prepare the data itself, the pipelines, and make it ready for models that are on it and querying. And so in that case, programming languages, which years ago used to scare us, but it is all very easy now, to be frank, And I saw someone, Habiba, also mentioned where we can also get materials. I used a link. It's called, I think the company is now extinct, but it's been bought over by HP, MapR. So if you go to learn.mapr.com, I think that's the link I can give you, but I think it will lead you to another HPE, that's a Hewlett Packard Enterprises link, and they bought it over. So you can get some courses that you can start off with. It starts from the scratch and then builds you up till you're able to a bit run on your own. So I use that. So some people might want to use that. So in terms of the new human task, I did say that it's not new, but then it is the scale at which we now need it for data engineers, for data analysts, for machine learning engineers, for artificial intelligence engineers, and even for data analysts. Thank you.
Can you hear me now? Sorry, I've seen that you worked with a financial institution before. So I would like to ask, the big data approach that they use, is it sustainable, especially here in Africa? Is it, something that could be consolidated upon, or there are areas that could be modified?
The big data approaches. So while I was working there, I didn't do so much. I didn't do big data, to be frank. It was data. So we were not getting from unstructured sources at the time. But if I check, I know that they are doing a lot with Bayes rule and models and putting the fraud analytical models are being used now, and of course it is based on an enriched data. So yes, the approach, if you're asking of the approach, to be frank, it's not that it is, well, the policy is, I think for companies, they are beginning to put in policies themselves. But I think at a higher level, we need policies from the government, that will also make people aware, to raise awareness, and then compliance, and then people begin to adopt, awareness, then people adopt it, and then there's a compliance policy that makes it very important for people, even companies who are already doing it, but then they are not guarded by some rules that they need to be guarded by. So yeah, I know that they're getting in data, but then to be frank, I'm not sure about the approaches that they're using to do what they're doing now.
Okay, do that. Okay, that's fine. I will just, two quick questions. One, since privacy has become a key issue, of course, in data management and data use, what are the methods you feel are in line with preserving privacy in the usage of big data?
Okay, so when you talk about privacy, as Professor Ashaolu has said, if you don't want any of your data to be online, don't get online. You get so yeah. One of the ways you can know these advanced field fraud guys is when they're not on WhatsApp, you can't trace them. So if you have your data and all that, it's going to be online. It now depends on how it is being used. But then the privacy, what I appreciate. So in South Africa, I'll use South Africa as an example. There is an act called the Protection of Personal Information, POPI Act. It came up in 2013, I believe, November. And as at July 1, 2020, this year, it was in play. And then it makes sure that you don't spread people's data anyhow, their personal information, the ID number, the name, the major information. It's discreetly used, and you give account of it, so there's a compliance, so they put in policies in place at a government level, and then they have given all companies a 1-year grace period to comply. So it's not something you come in and then you say immediately. It's almost impossible to immediately get into it. So it's going to be a gradual process. But then I like the fact that the policy is coming from above, and then it's coming down to all the private companies and even people who might even set up businesses to exploit this data in a way that is not right. They know that there is a policy, and if they are being caught, the truth is some people might still use it in the wrong way, but then there's a policy in place. So I believe putting policies in place that can help people, to guide people on how to use the data, how to spread the data, and who really needs it, who doesn't need it. Say for instance, there's also data masking, where you don't have to see all the details. Some details you don't need to see, and that is after authentication, the authorization, what you are authorized to see as far as the database is concerned. Thank you.
Okay, thank you. Lastly, how important is it for companies to hire a data scientist? If you are to rank this, how important is it for companies nowadays to hire a data scientist?
David, and to everyone, I believe it's very important. If you have there is, based on the scale at which you are working, I wouldn't encourage a startup that doesn't really, need to go pick up a data scientist, because, they don't come cheap too, but if for an enterprise, you need a ownership, and you need a direction. So I believe that those companies need to hire the competencies needed, in whether data scientists, machine learning engineers, even data analysts, and data engineers, as it were. But the scale at which they can come in. So if for instance a company for the size of maybe 1,000 employees, and they're doing there's a lot of data, you can have a chief scientist, a data scientist with maybe few tens of scientists, but then, and the others can be outsourced. And this is where outsourcing come in, where I know that even companies with data scientists inside, even if you have the money to hire 100 data scientists, will not, the perspective at which the researchers in tertiary institutions will look at it, and the depth, so at some point some of these competencies also need to be outsourced, and that's why we're saying we started with privacy policy. There's a policy that you can't use the data anyhow, but then you expect that the areas where you are not looking at research, and as an example, maybe not just data scientists, one of the choice tools that we use in data engineering, which is called Spark, a lot of people will know it. Apache Spark. Apache Spark came up from it was someone's PhD research in UC, I think, in the States, and it's the choice processing engine now, where they use in-memory analytics, and it used to be MapReduce, but then they adapted that, and so that tells you that our tertiary institutions should be encouraged to do this research by outsourcing it to them. They're encouraging them to even do more, to develop better tools, that we can use. I can't imagine if we were still writing mappers and reducers to ingest data now, if it was years ago. Spark just makes it easy. And there are many tools, that if we outsource this thing to tertiary institutions, it will also encourage them, because they have the time for this research. They have the basic and the background knowledge, to even make it better, so that for industry use. So that is, I don't know if I was able to answer.
Yes, you did justice to it. Thank you very much. So we'll just quickly run through a few questions from the participants, and I will just direct them to individual presenters. Professor Dosome, please.
Yes.
Okay, thank you. The question here is that you talked about data mining. Is this the same mechanism for crypto mining?
Yeah, that's a good question. No, it's not the same. Usually when we talk about data mining, we're looking at building models or gaining insight from particular data. When you speak about crypto mining, you're speaking about more on the blockchain side of things, which is really where miners are performing a specific mathematical operation and verifying transactions. So you'll have, for example, they had the old proof of work. Now it's proof of stake, Ethereum. So it's a different type of mining, and it's very mathematical and computationally intensive. So it's not really gaining insight from data, which data mining is. Yeah.
Okay. Thank you very much. Please, could you also shed light on this? the data gathering mechanisms that we could use in order to fight terrorism. I mean, to monitor the activities. Could you share your thoughts on this?
So you want to just want to get the question right? Is it? Okay. Yeah. Maybe you could just repeat the first part. I think you broke up a bit.
Oh, okay. The data gathering mechanism. How we could the important data that we need to harness to be able to monitor the activities of terrorists. Could you share your thoughts on that, please?
So I would tell you not just for transaction learning or AI in your transactions. So everyone banks, so you'll know that in your bank, all your transactions are monitored by your bank. And everything from where you did the transaction, who the money went to, when did it go to, what was the amount, and so on. So there's machine learning algorithms running in the background. Before it used to be done by people, now it's automated. So that data is constantly being monitored by these and pushed through these algorithms. So if there is some anomaly with a particular transaction, the algorithm can classify it into a particular type of transaction. And it's not just about fraudulent transactions, but it can also be looked at as, for terrorist type of transactions, because we know that terrorists also, there's different types of terrorism. There's cyber terrorism and different types. So financial institutions are really using this already, and they're able to detect particular, and governments can do the same thing as well, employ certain models to do that. Thank you.
Okay. Thank you very much for your contribution. Dr. Ashaolu, please.
Yes. Same question. Please. Okay, am I to respond to the same question?
Can you hear me?
I can hear you.
Yeah, okay.
You mean on terrorism? Well, aside monitoring, one's financial transactions. Hello?
Yes, I can hear you.
Yeah, aside looking for patterns, as to one's financial transactions, systems could also be in place to, as we mentioned earlier, that more or less track the sort of sites you visit, the things you do online. Similarly, government can equally, harness other resources like satellite imagery. For example, we can begin to look at, the satellite images, looking for specific patterns as to where there is unusual movement, especially our Sambisa forest, looking for heat signatures in pictures, where explosives are being detonated, probably for practice or whatever. So you can actually look for, all these traces via intelligent algorithms that will somehow link up, or flag someone as being a potential security risk, or a certain place as being an area of security interest. So those are some other possibilities.
Okay, thank you very much. Thank you very much for your insights. This question is directed to Dr. Ashaolu. Dr. Ashaolu, please.
Yeah.
for application area of or using big data analytics? Can it be used for natural language processing, particularly scarce language resources of African languages? Can BDA be used for natural language processing?
Definitely. And that's one area, you know, where we should be looking forward to some interesting results. I know some people in South Africa especially are working on that. And a couple of people in Nigeria also have been working in NLP, natural language processing, and I'm sure they want to go the big data analysis way. There is AltI, an organization based in Ibadan. And as I mentioned, we have some researchers in like and some other places looking at getting African languages on the web. I also know some Egyptians working in this area. So yes, there is need to incorporate big data analytics. We must make every effort to actually represent our various mother tongues, right, on the internet and in the ICT world generally. You find out that there are some standard languages are always used for ICT. You know, you have English, Russia, Italian, Portuguese, Chinese, Arabic, you know, about 7 or 8 of them. It's only of recent, you know, that corporations like Microsoft, Google, and so on are beginning to show interest in African languages, and they are actually, you know, collaborating with people here to develop these technologies. Yeah, so a lot of work is going on. And very soon, you know, we'll begin to see a lot of products.
Okay. Thank you very much, sir, for your contribution on this. Mr. Joshua, please.
Yes, sir.
Yeah. So how do you think we can demystify BDA to a level where it can be entrenched across all curricular teaching and learning in Africa?
The demystification of big data.
Yeah.
Okay.
Yes, to see how we can entrench it.
So to make it more pervasive, as in to make it more generic and push it to, you know, say for instance, all the schools and put in curriculums for, say, for senior secondary schools and mainly tertiary institutions. I think it still goes back to the policy, because I believe that, you know, the where we really need it to work more is the tertiary institution. So put it in the curriculum and make it. I think you need to break it down in the sense that, you know, it's a humongous framework. To be frank, anyone who has dealt with big data systems would know that every picosecond a new software is coming and a new. So define the basics, which is say for instance, at a point, big data analytics was very, very synonymous to Hadoop. A lot of people are still using it, but people are now seeing other ways, you know. But if we pick up, say for instance, that framework, Apache Hadoop, you know, and then break it down at the HDFS level, that's the Hadoop data file system level, and then the resource management level, the YARN, and then put in all the governance tools, the processing engine, you know, the security tools. So define a framework, a minimal framework, basic framework that a lot of people can ingest, and it can be entrenched into the curriculum, and such that a lot more people can now build on it, you know. So
interesting.
For things like exploiting it in terms of the data science tools, Python is a very, very good tool that a lot of people are using, you know, and it's becoming very easy. At least, you know, the much I've interacted more with a few people around in Nigeria, you know, it's now more ingrained in the system. So I know that at a point, you know, there used to be a fear for programming languages, you know, and then you rather go to networking or you go to information security. But that now, you know, it's a lot more, people are beginning to engage it, because for you to express yourself as a researcher, you know, some of us found it that, you know, when we came out to do research, you know, I did research at UCT for masters, you know, and one of the things that we needed to overcome, you know, was to get into make programming language or all these tools, to use them as a tool to speak the language of research. So if we begin to adopt these tools, say for instance, you know that MATLAB is a tool for computation, and there's no student that, you know, it's a course on its own. You know, it's not just a tool, it's a course at the elementary stage, and then you build on it. Python, same thing, you know, and you don't necessarily need to tell an electrical engineer to go through all the tools. You might not need a web app, you know, PHP, C++, maybe Java, Scala, other scientific tools, and some things he will probably need, you know. So we can start with that, and then we'll build on it. And you see that we're having people who speak the language the more, who are confident about expressing themselves, even in research, you know, and even want to get into more research, you know. And yeah, that's my take on it. Thank you.
Okay, very interesting. Thank you very much, Mr. Joshua, for your insights on this. At this point, I think we have exhausted questions selected for to be directed at the presenters. And also I must thank all the speakers for sharing their thoughts with us, and also to all the participants for staying put. I would like at this juncture to call on the leader of the organizing team to take it up from here. Thank you. Dr. Ibrahim, please.
Okay, thank you so much. But I thought you called the president. But anyway, thank you very much for the very insightful seminar. To all our speakers, we are saying thank you, Professor Wesley Dosami. We are very much grateful, sir, for honoring our invitation. We learned a lot. And to Dr. Asholu, thank you so much, sir, for quite very important insights from the Nigerian perspective. To Mr. Joshua Adeleke, you talk too hyper that some of us were struggling to follow you. Thank you so much. I'm sure the experts that are following, I can see the comments, they are really enjoyed your thoughts, while some of us were actually struggling. But by and large, it's very, very, very stimulating presentation. We learned a lot. To all members of the webinar committees, our webinar committee, we say thank you, the president of the NYA, Dr. Abiodun Betuku, the SecGen, Dr. Kazim Idu. Thank you so much to the other member, Dr. Temi Sobamu. Thank you so much for being here. And to all the attendees, we are very grateful, and we call on you to please keep following the NYA webinar, monthly webinar series, which we will be featuring at the last week of every month. Which will be coming with very important and topical issues for presentation at the end of every month. We say thank you very much. We are indeed very grateful. Before I round up, I'm sure the president will just say 30 seconds. Once again, thank you so much to the speakers and to the attendees. Please kindly do follow us for our forthcoming and subsequent webinars. Thank you so much. Mr. President. Hello?
Okay. Oh, yeah. Sorry, my microphone was muted earlier. I want to thank you all on behalf of the Nigerian Young Academy, all our speakers, Dr. Shaunu, Mr. Adeleke, Dr. Dosami, and all participants from whichever part of the world you have joined us from today. Thank you. And I joined the chair of the organizing committee to invite you to join us again in about 4 weeks for what promises to be another interesting webinar. The Nigerian Young Academy seeks to consistently contribute to matters that concern the development, first and foremost, of our country, and then by extension of our continent. So we'll be back again in October with another very interesting topic, and we do hope that you continue to keep safe until that time. Thank you so much.
Yeah. Okay, thank you so much, ladies and gentlemen. Until we meet.
Thank you for having us.
Thank you all. Bye.
Thank you so much. Yeah, bye-bye.
Thank you for having us. Thank you, Awa.
Thank you so much.
Thank you, everyone. Yeah, bye.
Bye.